Hello, the Astro 30 here, and today... What, sweet? Can you have another electronics video? Well, I guess, yeah. Greetings, the Astro 30 here, back again with another exciting installment of AEL, Astro's Electronics Lab. And today I've got this kit from Alltronics. The catalogue number is K5340 and it's a guitar preamplifier kit. The run date is interesting. It was last run on the 8th of September 2015, so yeah, not that long ago, about nearly 3 years, it'll be about 2.5 now. This kit comes from a published article in Silicon Chip magazine back in 2000. Not sure of the date until I get the instructions out and read the publication date. But basically everything's all on board mount, potentiometers etc. are all board mounted. That's the printed circuit board. There's an adjustable trim pot here which I'm not sure what that's for yet. It features onboard headphone amplifier as well, so yeah, you can power some headphones. I'm not sure if it mutes the output of the preamp yet. It has a bridge rectifier and a 7915 and a 7815 positive and negative regulator respectively. I'm not going to use them, I don't think. Because I'm going to be probably using a power supply that has its own 15 plus minus rail on it. Now it uses a lot of link wires because it's a single-sided board, and there's also a very long link wire which goes across the back of the potentiometers to ground them. They're using TL071 and a TL072. But mostly TL071. There's a TL074 here. I didn't realise there was a 16 pin IC there, 14 pin. 1, 2, 3, 4, 5, 6, 7, yeah, 14 pin. I didn't get an IC socket for that. Oh well. So my plans of using IC sockets may not work. However, let's get the instructions out and we'll have a look at them. This is the Erratas 2015. It says, "Dear constructor, we recently found some small errors in the printed circuit board used with this kit and we would like to take this opportunity to point out these errors before you begin. Firstly, there are some errors in the overlay text on the PCB. They are the MKT capacitor closest to VR3 marked as a 0.0027 microfarad. It should say 0.0022 microfarad. So closest to there, I can see that one's 50. Here it is. Yeah, down there nearest the. I'm not sure what pot that is offhand. Whether it's the base or the middle pot. It should be marked 0.0022, not 27 as it is. Okay. The resistor closest to pin 4 of IC3 is marked as a 4.7K. It should say 27K. That's a big error. So IC3 is there. 4.7K is there. That should be 27. The electrolytic capacitor between Q1 and Q2 does not have a value marked. It should say 10 microfarad. It doesn't either. So it's just a blank capacitor with no designator. Nice. Please note that figure 4 of the instructions, however, is correct. So I assume figure 4 of the instructions would be the overlay to the PCB. However, it's printed wrong on there. Secondly, it was found that the PCB holes for the 2 headphone sockets do not fit the actual sockets. There are a couple of ways this can be worked on. Okay, you just need to drill them out. So that means that these sockets probably don't fit the PCB properly, so I'll just grab one of the sockets and I can see right away, yeah, I don't think those holes are big enough. Let's see if that fits. Well, one side does. they're actually offline too. They don't even really fit. I suppose with a bit of bending of the pins they'll fit, but right now they're not fitting. Yeah, a bit of massaging, those pins will fit in there. Now, they're showing two identical input channels. They're both identical to each other, but you need to buy a second module to make that work. So the one in the dotted line here is the same as this module up here. So we ignore that because I only have one. And what we have here is we have the main input preamplifier, the level control, what looks like another amplifier there before the tone control network, which features bass, mid, treble. Then it looks like it goes into the first mixer, which would be, I reckon, a summing amplifier rather, which also is part of the effects send and return, into a second mixer, to the master volume, to an output buffer for unbalanced output, and before the volume control into a balanced output buffer. And then we've also got from the output of the buffer, we've got a headphone amplifier. So let's have a look at the schematic. Well, here we go. There's two identical channels here. They're both the same because they're two of the same PCB, so we ignore this bottom one. So the input comes into the first half of a TLO72, and it's set to a gain of 4.9 by these resistors 4K7 and 1K2. It's got a little bit of high frequency filtering on the negative 15 and positive 15 volt rails respectively, and that goes into one side of a non-inverting op amp of a TLO72, which is then fed into the first level control, which is a 10K logarithmic pot. It then moves into another amplifier stage, which is before the band axle circuit over here, just out of shot, and that's using the other side of the TLO72. We've got a gain now of, if we divide that, we'll say that's around about a gain of 10, because it's 10K divided by 1.2K plus 1, so yeah. If I just do a quick calculation, we're looking at a gain of 9.3, so pretty close to 10. And that's fed into the band axle circuit over here, which is based around this inverting op amp TLO71, and that's what that trim pot is for, is adjusting the DC offset on that particular IC, because they have two extra pins there. And then that's then fed out into this resistive mixer here, performed by both 33K resistors. And I was right, it's going into a summing amplifier, which sums these two channels together, or mixes them, using a inverting stage here, another TLO71. The output of that is then fed through to the effects send socket, I couldn't think of the word of it. And also part of it's then fed into the next amplifier stage, which is a buffer down here, which also is part of the effects return. And there's also a line input down here too, just out of shot, line input as well, which is kind of nice. That goes into the buffer stage here, that goes into this mixer stage here, which is mixing both the line input and the effects send return and the output of the preamp together. So that's another basically summing amplifier, inverting stage. And then we go into this balanced section here, which is comprised of, they're using a quad op amp here, but they're using two channels of it to do the 180 degrees out of phase signal for the cold pin of the balanced output, and using a non-inverting amplifier up here to form the hot. So that's inverting, that's non-inverting, that gives you your 180 degree phase shift, and hence giving you a balanced output. And using a transformer is doing the same thing, except it's not a active component, it's passive. But a lot of good quality gear uses transformers. They're using an op amp. You can achieve the same thing. And of course down the bottom here we've got a main volume control, so that balanced output comes before the master volume control, which is then just fed into a non-inverting amplifier here, which by the looks of it is set to unity gain because it's just basically a direct short circuit from the inverting input to the output with a 150 ohm resistor in between, so it's not a direct short, but you would say that would be operating in a gain of 1-to-1 or unity, so it's not actually producing any gain, which then goes to the output socket for the unbalanced output. Also, we're going through a standard headphones amplifier here using an op amp with a transistor push-pull stage attached in the feedback loop of the IC, just so that these transistors can drive a higher impedance load such as headphones. You don't want to connect them directly to the output of the IC. The IC won't like it too much. And on here they've got headphone 1, headphone 2, but there's only really provision on the board for one headphone socket. But it looks like they've given us 2 PCB standoffs on the headphone socket section to probably connect to a headphone socket off the board. Anyway, I think I've done enough talking about this stuff. It's time to actually build something. So, yeah, let's get started. I'll probably do it in time-lapse like I normally do, even though that takes a hell of a lot more time to edit, but it is what it is. So, yep, time to get started. Wow, the board just fits in the tool. Yep, that's probably maxing out the actual length of this tool. This board's about probably 250 millimeters in length. Anyhow, it's in there, so now I can start assembly. I was going to just mention one other thing. You've probably worked out by now what my next major project is. I'm going to combine this preamplifier with that power amplifier module I built last week, that 115 watt one, and make, yes, you guessed it, a guitar amplifier. Mainly designed for bass, I guess. It shouldn't really matter, I mean, it will work for either. But yeah, that's the plan. I was going to use IC sockets. I might use one here for the first op amp stage in case I want to change that to a lower noise, and for, well, these other 3 I guess. I just can't use one for there, which is annoying because I don't have one. But if I ever want to remove it to change it, well, I'll just unsolder it. Anyway, getting on. So as I'm turning this into DC, I need to work out where to put link wires for the path for the voltage. So that's one side of the AC input. There's the diode that then goes into the negative regulator, which then goes, where do you go? Let's see. So the center should be the input. That would be the 0. Pretty sure that's ground. Yeah, that's ground. So that's the output there. So that means I have to put a link there, and I know I'm going to have to put a link across these 3 here, but not the center, because the center is also ground. So that will then go, that's the what is that? That goes to here, which should be pin 8. Yes, it is. So that's the positive rail. So that means that this diode has to have a link across it as well. No, that would be incorrect, because that would be then shorting this diode to that diode, or shorting that rail to that rail, so it'd have to be that one. So that'll become my positive input, and that'll become my negative input. So I'll just mark that with the black markers to indicate where negative is. So it goes negative, positive, and ground there. There's also another ground there. For some reason they've got 2 ground points. Okay. Okay, that's the assembled circuit board done, apart from the pots and the jacks. Now, the values of capacitors they've chosen here, like, well, the voltage anyway of these non-polarized caps, make them too big to fit in the footprint that they're designed for. That's, yeah, it looks like shit, but it's still functional. But still, would have been nice if they'd, like, you know, you don't really need 50 volt non-polarized caps there. You could get away with 16 volt. It's only in the signal path. Anyhow, also these holes for the effects send, return, and some of these grounds here are too big for PCB pins, so I've left them off. Now, the next thing to deal with would be the jacks here. Now, they say in the errata that the holes are off, and I think it's more off in the long ways direction than anything else. What I'll try is just bending those pins out slightly. Let's see how much difference that makes, because it looks like I might have to drill. I'm going to drill it from the copper side. Technically speaking, you shouldn't have to do this. I mean, it would have been nice if Ultronics had actually checked it before, you know, drilling it, and then made the modifications necessary to make it fit. But that's the best I'm going to get it. Both sockets are the same, so it doesn't matter which side you put them on. So it's just a matter of soldering it in now. And as long as you can still solder to the pads, and there's enough meat there to solder to, then yeah, drilling is the best option. They do say putting some tin copper wire in there, making it like a standoff sort of thing. You could do that too, and probably get it more vertically central with the pots, but I'm not really going for that at the moment. Okay, with the pots, what I would do is I'd probably move the circuit board out of the way, and I would just file the surface until you can get solder to adhere to it. You don't have to go too far with this, just enough to take the surface off. So I will solder the centre lead in, tack it in just so it holds into the board, like so. Next is 100k lin, which is B100k, log is A. Remember that, B is linear. Same sort of thing. So that's the pots soldered in now. I just need to straighten them up as best as possible. And now attempt to solder across the top of these pots. They did say to do it across the back, but it doesn't really matter. Because, so you can do it. Just takes a bit of heat. So this soldering iron is pretty good for that. So we need to now get this to solder in. At least start it anyway. And that's it. That is the preamplifier complete. Isn't that special? So I'll start by making sure that all the pots, like volume pots, are down low, and these tone controls are in the center. And and these nuts aren't going to go falling off. That's the effects pot, so it shouldn't really need to be turned up. And turn that one down. Now, need to hook it up to some power and oscilloscope and see what it does. Of course, before we can do that, we have to do some preliminary tests, which is powering it up and checking that if you're using the voltage regulators and bridge rectifier, etc., that all the voltages across each of these ICs is correct. You know, you've got plus minus 15 there. We know we should because I've just bridged them. And the second thing is we have to adjust VR7 here, which is the DC offset. So we connect a positive multimeter probe to this PC stake here, which is called test point 1. The negative probe to a ground somewhere on the circuit, and we adjust this VR on the millivolt range of our multimeter until we get as close to 0 volt as possible across that adjustment, and that'll complete the I want to say calibration, biasing if you like, of that part of the thing, and then we can actually do the tests. Okay, got everything hooked up. Yeah, it's okay. Got the multimeter set to the millivolt range. Currently the load is off on the power supply. That's set to plus minus 15. Excuse me. Now, just power it on and see what happens. Well, not much. We're getting a current draw of 20 mA, which is fine. And that's a minus 62 odd millivolt. Just checking that IC is not getting hot. So now I'm going to adjust this variable resistor. Currently we're at minus 1.82 millivolt. So I'm just going to carefully turn it in the counterclockwise direction. Now we've gone too far. Would have been nice if they'd used a 10-turn pot. Because this is very touchy. It's almost roughly at the center position of its travel. There we go, I managed to actually fluke it. How about that? Now we're at 0 millivolt, or close to. So, now to hook up an oscilloscope and see what happens. Okay, I've got everything set up now. Got the oscilloscope set to the unbalanced output for now, because those pins are awfully close together. Got the signal generator hooked up to an audio cable going into the input, and it's hooked up across the other end of the cable. I think I said we're set at 1 kilohertz. If I didn't, I did now. So turn the load on. Still got 20 mA, nothing on the oscilloscope screen, of course, because none of the volume controls are turned up yet. So if I start winding them up, I should see an output, which I do. That's with the input all the way up. And that's with the output all the way up. And we're getting a good peak to peak of 11 volt there. I might just change the... See, though, the thing is, that is a very noisy signal. That's the treble increase, decrease, so that's actually the treble circuit doing that. That's the mid-range, 26 volt peak to peak, that's nice. And the bass, well, we won't see much at this frequency that we're using at the moment, so I might change the frequency to 100 Hertz. There we go, 100 Hertz. Just adjust the seconds per division. Now that should be the bass pot there. There we go, it's increasing. It's 29 volt output, but oh my god, look at how look at that extra I'm not sure what you call that, superimposition there. Looks like it's oscillating. Okay, so we know that the tone controls actually are doing something. the effect control doesn't seem to make any difference on the output. Now that's only at 175 millivolt input, which is, well, your average instrument anyway. So let's change the input voltage to around 500 millivolt, which didn't change. Don't know why, this is a silly little thing. So now we're at 100 millivolt and we've got our oscillation back there again, which goes away if I decrease the input. So it's actually clipping badly there. But at 500 millivolt in, we are getting 24 volt peak to peak out before clipping, which is quite powerful. So we know that that works. So I'll change that to, yeah, around about there. Now let's do a sweep on that and see what it looks like. Well, it appears to be reasonably flat. So hovering around about 12, 11 and a half volts there. Starts at 15, then rolls off to about 11 volts. So it's not perfectly flat, but I might not have my controls exactly centered either. But I can see that it's actually functioning as it should be. There is a headphone output here, so I might actually hook up the oscilloscope's output, or input I should say, to the headphone output, and I can see there is an output signal. I just don't want to short that together, so I'll put the earth back there. No, that doesn't want to work that way. Okay, don't work that way then. I'll connect you across there then. Okay, now with the sweep we can see that, yeah, it is outputting. So if I plug a pair of headphones into that, I should actually hear that coming out. Plug this into the socket. Oh, I can hear that. So yeah, that's working. Put it back to 1 kilohertz. Yeah, there we go. Just see how that sounds. Sounds reasonable. Okay, that's enough of that. What I might do is I might hook up my bass to the preamplifier and have a listen on the headphones and see how it sounds. So that's the next thing I'm going to do. I might jam that lead under the power supply so it doesn't pull the board off the desk. Okay, so if we look at the oscilloscope, we can see it's doing something. I'm not sure it's coming out of the headphones yet. I'll have a listen in a sec. Oh yeah, it's working nicely. Alright, not that you can hear it, but there's one little problem with that. Because I have negated the regulators and everything, I can't actually hook up a decent power amp to it, to a speaker. Not the power amp module that I built anyway. However, that Class A module I've got will run between 12 and 24 volt. So I'm going to hook up the Class A module to a speaker to the power supply, because I can, and then we can actually hear the preamplifier's output. So I'll turn the load off and get doing on that. Okay, I believe I've got that hooked up properly. I've just used the other heatsink that I had lying around and just clamped the module to it. Now I'll turn it on. It works, but it's distorting the speaker a bit because it's not designed for bass. So I'm going to turn the bass right off. Okay, so that's a little bit too MIDI. Okay, anyway, I'm going to try a different speaker. I'm going to try one of those 16 ohm speakers that I've got lying around. Well, the only one I've got lying around that actually works, because that should be able to handle the bass a bit better, even though it's only 16 ohms. So I don't want to blow that desktop speaker up, so just to give me a second. Okay, take two, I've got a different speaker, which actually sounds a bit better anyway. So now, let's see what this preamplifier can actually do. Now I can increase the bass. That's distorting too much. Leave it at the centre. Turn the bit back up a bit. Yeah, I need to practice that a little bit more. I've stuffed it up. It's still distorting just a little. I think it's the input more than anything else. Could be the speaker driver too. Or it could be the power amplifier, who knows. Speaking of which, yeah, that's alright. Pretty good. It's actually working quite significantly well, that I'm quite actually impressed. I mean, I did pay $60, about $65 I think, that's including the postage, to get it here from Ultronics. I will put a link in the description for the article so you can actually order one. And I think I'm out of tune. That one's right. There we go. So yeah, I'm actually quite happy with a decent power amp and a decent speaker that's designed for bass. I can get one for about $200, 12-inch. It's designed for both PA bins and bass guitar, so yeah. I might have to tone the gain down on the input stage a bit because it might be a bit high for bass, because don't forget you can also have an active bass which has active pickups on it, so it's got its own preamplifier on it, and it can totally distort the input extremely badly. So hit for copyright on that. Yeah, so that driver on the floor is crap as well, but yeah, it's working pretty well as a preamplifier. Took me about 2.5 hours to assemble, just saying, so give yourself at least, 2 or 3 hours. The power amp might be distorting too because it's only running on 15 volt. It's really designed to run on 24, so it's probably clipping way too early. Anyhow. enough of that. That's not exactly how the song goes, but anyway, it's close enough. I was just doing basically a groove around G, E, and A flat. Anyhow, I think I'm going to end this video here. It's gone on way too long, but you get the idea. So as always, remember to rate, comment, and subscribe below. And I'm the Astro 30 saying, see ya, have a great day, happy assembling. Shee.